Hello there. We continue our revisions of Form 4 Physics Chapter 4, okay, on heat. So let's go straight to the business. So 4.1 thermal equilibrium. Okay, what is a form of energy? So this is heat. Okay, heat is a form of energy. And then temperature is the degree of hotness. People always confuse these two terms. Okay, they are not interchangeably. Heat is not temperature, temperature is not heat, heat is a form of energy, and temperature is the degree of hotness of a body. Alright, so when two bodies are in thermal equilibrium, so there is no net flow of heat between the two bodies. Okay, so meaning to say that the net flow of heat equals 0, and then the rate of heat flow in both directions must be equal. They must be the same. And whenever we have two bodies in thermal equilibrium, the temperature of the bodies is also equal. Okay, complete the following tables with figures of a liquid in glass thermometer. Okay, so what features of the glass bulb that enable heat transfer by conduction is faster and thermal equilibrium can be reached faster. So here we are talking about conductions of heat. Okay, so the glass bulb must be thin. Okay, next, the bulb itself must be small. Okay, so that it can only occupy a very small amount of liquid, and we do know that having small amount of liquid, it is more responsive to heat. Okay, next, narrow. Okay, narrow and uniform bore of the capillary tube. So this will make sure that the contractions and expansions of mercury, it is more sensitive, okay, for a very small change in the temperature. Okay, other than that, the contractions and expansion will be even, or in other words, are uniform. Okay, next, the wall of the long tube above the bulb, it must be made thick. Okay, what is the purpose of having thick walls of long tube above the bulb? It will act as a magnifying glass, okay, to ease reading. Okay, so that is the features of a liquid in glass thermometer. Okay, we move on. In order to calibrate a thermometer, we need to know two known fixed points. So these two known fixed points, namely the freezing point, okay, and then the other one would be the boiling point. Okay, take for example, if we have water, so we know that the freezing point of water would be 0 degree Celsius, and the boiling point of water would be 100 degree Celsius. So this is the two known fixed point, the value that we know of. Alright, so we go to the next one, number 5. The temperature of liquid can be determined by using the following equation. So this equation must be very familiar to you. Okay, whereby theta equal to L theta minus L 0 degrees Celsius divided by L 100 degrees Celsius minus L for 0 degrees Celsius. We take the fractions and multiply by 100 degrees Celsius. So this is actually ratio. Okay, so LO will be the length of mercury at the freezing point. Okay, or 0 degrees Celsius for water, and L100 is the length of mercury at the boiling point. okay, which is 100 for water. That's why we have here 0 and 100, whereby L theta will be the length of mercury at theta point. Okay. Here is questions on this uncalibrated thermometer. Okay, an uncalibrated thermometer is attached to a centimeter scale and read 5 cm in pure melting ice and 30 cm in steam. Okay, pure melting ice and steam, meaning to say, the length of the mercury column at 0 degrees Celsius. Okay, that would be 5 centimeter, and then the length when the temperature is 100, that will be 30 centimeter. So these two are the known fixed points. Okay, this is the freezing point, this is the boiling point. And then when the thermometer is immersed in liquid Y, the length of the mercury column is 15 centimeter. All right, so that will be my L theta. We don't know the temperature, but the length is 15 centimeter. So find the temperature. So our formula just now is theta equals to length at theta minus the length when the temperature is 0 degrees Celsius, and then the length when the temperature is 100 minus the length when the temperature is 0 or the freezing point, and then we multiply by 100 degrees Celsius. Alright, so L theta is 15 minus LO is 5 divided by L100, that will be 30, minus LO is 5. Okay, multiply by 100 degrees Celsius, and you should be able to get the answer 40 degrees Celsius. Alright, so that is the temperature of liquid Y. Okay, try to understand how we work the problem out. Now, let's go to question 7. Okay, now the distance between 0 degrees Celsius and 100 degrees Celsius is 25 centimeter. Okay, try to understand this statement. What does this statement infer? Okay, it simply says that the difference in terms of the length between L100 and L0, right, is 25 centimeter. Okay, when the thermometer is put into a beaker of water, the length of the mercury column is 16 centimeter above the lower fixed point. Okay, so what is this? It is actually our L theta minus L0. Okay, L theta is above the lower fixed point by how many? Okay, by 15 centimeter. And you are to find what is the temperature of the water. Alright, so again we write the formula. If you notice that before I solve any questions, I will write the formula, the equation first. Okay, so theta equals L theta minus L0 divided by L100 minus L0 multiplied by 100 degree Celsius. Okay, L theta minus L0, that is 15. Okay, L100 minus L0, okay, this thing here, that would be 25. Multiply by 100 degree Celsius. Okay, so this one here is 64 degrees Celsius. Okay, do you get it? Okay, make sure you understand how we go about solving these questions. Alright, so we move on. What is the length of the mercury column from the lower fixed point at temperature of 30 degrees Celsius? Okay, so now we want to know, okay, from L 30 degrees Celsius, sorry, from L 30, that will be our L theta actually. From L 30 to L 0, okay, the difference is what we don't know, right? L 100 until L 0, okay, this is given before, that will be 25 centimeter. Okay, so I will just write here 25 centimeter. Okay, and then theta, okay, is given 30 degree Celsius. Okay, so using this information, we substitute this into our equation. Okay, so theta equals L theta minus L0 divided by L100 minus L0 multiplied by 100, okay, degree Celsius. Okay, now, so theta here is 30 equals, okay, L theta minus L0 is what we don't know, okay, so I will write that as L30, okay, minus L 0. So I am just replacing theta with 30, okay, because theta here is 30 degrees Celsius. Alright, divided by L100 minus L0, that is 25. And then multiply by 100 degree Celsius. Therefore, the length of the mercury column from the lower fixed point, okay, that will be this thing here, okay. So I will write it like this. I have L 30 degree minus L of 0. That will be 30 multiplied by 25 divided by 100. So what do you get? Okay, so that would be 7.5 centimeter. So this is the length of mercury column from the lower fixed point at temperature of 30 degree Celsius. Okay, so try to understand, okay, how we solve the problems. Okay, we move on to question 8. Okay, now I have Alice Ho representing country. Okay, research project on the weather at the North Pole. The surrounding temperature is negative 40 degrees Celsius to negative 8 degrees Celsius. And then one item of the equipment to be taken for the research is a thermometer. So here you are given 4 types of thermometer, PQRS, okay. So based on the above table, state suitable characteristics of the thermometer. But as usual, before you go ahead answering the question, you need to know the objective, okay. So the objective here is to find a suitable thermometer, whereby the thermometer is to be used at a surrounding temperature of negative 40 to negative 8. Alright, so based on the table above, state suitable characteristics of the thermometer, okay, in terms of the liquid. So you only have 2 choices, mercury or alcohol, okay. Mercury, the freezing point is negative 39, and alcohol, the freezing point is negative 112. So which one is better? Which one are you going to bring, okay, to do your research at the North Pole? So definitely I'm going to use the freezing point of negative 112. Why? Because at the North Pole, the temperature, okay, the temperature at the North Pole is negative 40 degrees Celsius, okay, until negative 8 degrees Celsius. That is the surrounding temperature at the North Pole. So if I am to choose 39, so 39, what happened? Mercury will be frozen, right? So you are not going to be able to use the thermometer. So that's why we need to use alcohol, because the freezing point is lower. Okay, it go beyond negative 40 degree Celsius. Okay, so the liquid used here would be alcohol. Okay, reason would be low freezing point. Okay, so meaning to say alcohol will only be frozen if the temperature is at negative 112 degrees Celsius, which is way beyond the surrounding temperature at the North Pole. Alright, enough with it. So we go to the next aspect, diameter of capillary tube. Okay, diameter, I have big and small. So the capillary tube here, so definitely I will need to choose a small one, right? Okay, so I choose small diameter. Okay, small diameter. Why? It will be more sensitive. It can detect changes, okay, even the slightest change. And then the thickness of the wall bulb. So here, the thickness, I have two choices also, thin and thick. So which one do you choose? This is about the wall bulb. Okay, the bulb itself, the wall of the bulb. So I am going to choose thin. Alright, so let's write the answer down here. I choose thin. Why I choose thin wall? Again, it would be more sensitive. Okay, so it will be able to detect small change in the temperature, or easier to achieve thermal equilibrium. All right. Okay, so based on your answer in A, choose the most suitable thermometer to be taken to North Pole and then give your reason. Okay, so we go up here to this table. So P, I only have one tick. Q, I have one tick. R, I also have one tick. Okay, and then S, I have three ticks. So which one are we going to choose? So definitely S, right? So to answer these questions, we will write S is chosen. Okay, reason, repeat what you have written up here. Okay, so in terms of the liquid used, it's using alcohol. In terms of the diameter, use small diameter. In terms of the thickness of the wall bulb, we choose thin. Okay, so just repeat the answer just now. So just simply write it uses alcohol. Okay, which has lower freezing point. Okay, and then it has small diameter of capillary tube. And finally, and thin wall bulb. Thin wall of the bulb. This is funny English. Okay. Can you follow our discussion? Okay, so I stop here and we will continue in a sec. See you.